Okay, so section 2.3, we're looking at how to find the focus in directrix of a parabola. This is a new set of vocabulary that we have not talked about before. So this focus, this is going to be P units inside the parabola from the vertex. P units inside the parabola from the vertex. Might be a little clearer to say P units from the vertex and it's inside the parabola. But I'm going to describe it so you can see what I'm talking about. What we're going to be doing is we're going to be more specific about the parts of a parabola. So this focus right here, whatever this vertex is, the focus is going to be P units inside of that parabola. See how all of those are inside of it? Okay, then we're also going to have this line, and this line is the same distance from the vertex as the focus. The same distance from the vertex as the focus is from the vertex. All right. Okay, so let's look at this again. So right here's this line, it's called a directrix. Can you see how it never touches that parabola in any of these cases? So this directrix is always outside of the parabola. And the way the whole parabola is created is that every point on here, so this point right here, this is the same distance as this is. And in this case, this is going to be P distance away, and that's going to be a P distance of P. If I take another point, though, I could measure this distance right here, and this distance here would be exactly the same. So that's how the parabola is created. Every point on the parabola is the same distance from the focus as it is to this directrix, as it is to this line. Okay? A lot of these parabola shapes are used when we have things like radar, things like that, or a satellite dish, that kind of thing. We have like an antenna that comes up, and a lot of times that antenna will end at the focus. But that's how that parabolic shape is actually created. So we're going to have two cases at first. Anytime we have y equals a, see we have a new name for a. A is now going to be 1 over 4p x squared. So we're going to use that if the parabola opens up. We're also going to use that if the parabola opens down. Again, remember, this distance is P, this distance is P. Same thing here. This distance is P, this distance is P. The thing that is going to be different is, first of all, we're not calling this A anymore. This is a new form. Okay, so A is actually, when we have y equals ax squared, A is the same thing as 1 over 4p. We just haven't known that up to now. See how A is this coefficient of x squared? Well, that's the same thing as 1 over this 4p. So if I know this distance right here, I just do 1 over 4 times that distance, and that's going to tell me the A value. It's going to make some problems easier than they used to be. Notice that this directrix, if we're opening up or down, it's always a y equals equation. But if we're opening left or right, see how this is opening to the right? Look at everything that changes. Now our equation is x equals 1 over 4p y squared. And if we open to the left, it's going to be x equals 1 over 4p y squared. But just like up here, if it opens down, this p value is negative because it opens down. Over here, if we open to the left, that p value is going to be negative. It's kind of hard to understand all of this without an example, so I want us to do an example here together. So we're going to find the equation for the parabolas below. All right, so our first one, I'm going to give you some hints about it. We're going to say that the vertex is at 0, 0, and the focus is at 0, negative 4. And we want to come up with an equation. Now, it used to be that I would have to use this y equals ax squared, and I would have to plug in for x and y and find a. I could still do it that way, but we're going to try using this form now. Okay, so here's my vertex of 0, 0. Here's my focus right here. Okay, so first of all, is this going to open up, down, left, or right? Down, because the focus has to be on the inside. If it opens down, I know it has to be a y equals equation. Here's the way I remember it. This has two x's, so it's x squared. See how this would have two y's, a y value here and a y value here, and this is y squared? That's how I remember it. All right, so I have two x's. I have an x here and an x here, so I know it's going to be y equals something x squared. Remember that this number here is going to be 1 over, and then what's this p-value? How far apart are these? 4, right? So it's 4 is going to be the p-value, so it's 1 over 16. But what else would I have to put? It's opening down, so what's this a value have to be? Negative. Okay, and that would be our equation. We would have got the same answer if we had done this the other way, but it's just a little bit faster this way. Let's do another one. Okay, this time let's say we're given a focus. Our focus this time is going to be at negative 2, 0, and our directrix is x equals 2. Again, I would recommend you draw a little picture. It helps so much. So if our focus is at negative 2, 0, and our directrix is at x equals 2, this is the way it's going to look. Now, remember how the vertex has to be right in the middle of these two, because it has to be equidistant from each of them. So where's our vertex going to have to be? 0, 0. We also need to know which way does this open, up, down, left, or right. What is it? Up, down, left, or right? Look at it, can't touch the directrix, and it has to wrap around the focus, left. So do I have two x's or do I have two y's? Two y's. So it's going to have to be x equals something y squared this time. So now I have to figure out what the something is. Anybody know how I can do that? How can I find out what this value is right here, the new way? Exactly. How far is it from here to here? Or how far is it from here to here? 2. So I know the p-value then has to be 2. And I know that this value right here has to be 1 over 4p. So what's it going to be here? 1 over 8. Now, is it opening in the positive or negative direction for the x's? Negative direction. And there we go. Okay? Questions on that? So the new things we're adding on are really the 1 over 4p instead of thinking of it as a, and the right and left concept. And we're going to keep going. Okay, so now we're going to go a little bit further with it. Still the same concept, but now we're going to be shifting it. We're going to shift it right, shift it up, shift it left, shift it down. All right, so how's that going to change things? Well, look at these two. They open up or down. X is still getting squared. We still have y equals 1 over 4p, but now whatever that vertex is, it's x minus h squared plus k. Okay? I don't have you memorize these. I think it's easier to understand these instead of trying to memorize them. So I am not going to even talk about the way that they have you find this. I always just think to find the focus, I'm going to go p units inside. To find the directrix, I'm going to go p units outside. Much easier than trying to memorize these formulas. Same thing here. Focus is p units inside, directrix p units outside. For all of these, that holds true. So let's now look if we have a horizontal axis of symmetry. So a horizontal axis of symmetry right there. This is when we open to the right or open to the left. Look at the difference. This is now going to be x equals 1 over 4p y squared. But that vertex, the k value, that's going to be the y coordinate of the vertex. And this h value is going to be the x coordinate of the vertex. So it's really the same formula. It's just that y has to go with y, and now the x goes on the outside. That's different. We've never had that before. So let's do a couple of examples with this now. All right. So we're going to, I'm just going to draw a picture as I go with this. So we're going to put our vertex right here at 2, 1. I'm going to put my focus down here at 2, negative 2. And we're going to try to come up with this equation. All right, so some questions we have to ask ourselves. Which way is it going to open? Up, down, left, or right? Down. It's going to open down. It's going to look like this. Is that going to mean that it's y equals x squared or x equals y squared? Y equals x squared, but I'm not going to write that all out yet because I have to do some changes with it. So I know it's y equals, okay, now I know the vertex, right? So I know it's going to have to be x minus 2 squared plus 1. Everybody agree with that? This is h, this is k. I have to keep my x with my x, and my k goes out here. And then how do I figure out what goes here? It's got to be 1 over what? So what is it? It's 4p. What's p?
2.
Is it 2 from here to here? 3, isn't it? Isn't that the distance? 3? Count it. 1, 2, 3. So what's going to go under here then? 12. And then what about the sign? Negative.
So p is the distance from the vertex to the focus?
Yep. And we can write that. Let's put that in here just to make sure everybody has it. P is distance from vertex to focus. And it's also the distance from the vertex to the directrix if we go directly down to it. All right, and that kind of shows you that here. See how this is p units over and p units over? All right, let's try another one now. All right, so I'm going to draw it as we go for this example. Okay, here's going to be our vertex. Let's put it down here at 2, negative 1 this time for the vertex. And I am going to put the directrix over here. So my directrix is right here at x equals negative 2. So x equals negative 2 is my directrix. So I've got my vertex, I've got my directrix. So which way is it going to open? If this is my directrix, the parabola can't touch the directrix. So it's got to open to the right. Okay. So what does that mean I'm going to have? X equals something y squared or y equals something x squared? X equals, doesn't it? Because I got to have 2 of the y's. X equals. Okay. Anybody know what the p value is? Maybe we want to write that down. Yep. So the p-value is going to be 4. Okay, do I need to, so it's 1 over what? Does it need to be positive or negative? Positive, it's going to the right. Okay, now we're going to have to clean this up a little bit because I'm going to have 1 over 16 and then I need y squared. But what's going to have to go inside of here? What's the vertex value? So I have to do y minus negative 1. So I'm going to have y plus 1 squared. And then now instead of having a k like we're used to, we have to switch it to the h. So what's it going to be? Plus 2. That's going to be the equation right there. Okay? That's what's hard to get used to, and I'm telling you on the test, that's going to be the harder type of problem. Because it's, you got to remember that this has to be the vertex value of the y value of the vertex. This has to be the x value of the vertex. Inside the parentheses, it's always the opposite of what you would think. Outside the parentheses, it's the same as that, same sign. Okay? All right, let's have you guys try one. Let's have you try this number 1 here on your own. Think it through, and then I'm going to ask somebody to kind of explain it for me and tell me what they got for their answer. I would make it go by 2s on your axes to fit it in there. You should be getting pretty close. I'll keep working, but Charlie, do you think you have it?
I think so.
What is it?
Mm-hmm. Y equals negative 1 over 32 x squared.
Do we agree? Yep, that's right. You should be pretty close to getting that. That p-value from the vertex to the here or vertex to here, that was 8. So if 8 is p, this has to be 1 over 4p. It opens down, so it had to be negative. Very good. Most of you get that? Getting there? Pretty close to getting that? Okay, great. Let's flip over to the back now. We're going to do number 5. Okay, so it says to identify the focus, directrix, and axis of symmetry of the parabola. So we're going to do this together. So first of all, we need to know the vertex to be able to find any of the rest of that stuff. So what do you think? Haley, what's the vertex?
-1, -3.
Good. So I'm going to go ahead and graph that, -1, -3. I like to graph as I go. Okay, so next thing I'm supposed to find is the focus. This is kind of tough. Right here is my 1 over 4p. Remember how in this spot that has to be 1 over 4p? So if I have 1 over 4p equals -2, I have to know what p is in order to find the focus. So I'm going to have to cross multiply, and I'm going to get -8p equals 1. So p then is going to be -1/8. All right, see how I did that? This spot is 1 over 4p. It's equal to -2. I just cross multiplied. I solved it. There's my p-value. So what that means is, because this is opening down, I have to go down 1/8 of a unit. I can't even really see what it is. So I've got to just think about it. If I go down, my x doesn't change, but I'm going down 1/8 here. So if I go down 1/8, that's going to be -3 1/8. Everybody get that? Understand why? It's just we're going to use fractions on this one. And then to find the directrix, the directrix is going to be in the opposite direction. So if I go down for my focus, I go up for the directrix. Hard to even squeeze it in there. It can't be exact. Can anyone give me the equation of this line? Is it y equals or x equals? Y equals, so my directrix is going to be y equals, and then from here I had to go up 1/8. Know what that's going to be then? Yeah, what's it going to be, Henry? All right. I just had to go up 1/8. So -2 7/8. All right, so I've got the directrix, and the last thing I have to do is find that axis of symmetry. I don't know exactly what that looks like. That's good enough. And the axis of symmetry comes right down here through that vertex. What do you think? What's the equation of that going to be, Kate?
X equals -1.
Good job. Okay? So not too bad, just adding on a few more components, the vertex and the focus. All right, let's come down here. We're going to do one of these. Let's do a tough one. Let's do number 7. Okay, so on number 7, they're telling us the vertex. The vertex we can see is at 0, 0. And they're telling us the directrix is -7/12. That's what x equals. Well, remember our p value. P is just the distance from the vertex to the directrix. So what's the p value going to be? How far apart are they? 7/12 is going to be our p value. To write my equation, though, I'm going to have to use 4p, aren't I? I have to do 1 over 4p. So what do I get if I multiply that by 4? 28 over 12, reduce that? Or just do 4 and 12 simplified? You might know it? Okay, guys, here's how you can do it. It's going to be 7 over 12 times 4 over 1. That divided by 4 and that divided by 4. So it's 7/3.
Why is it 4 instead of 1/4?
Because I am trying to write my equation. So when I'm writing my equation, the equation is going to have to go x equals 1 over 4p times some y squared, something like that. So I have to know what is 4p before I can do 1 over 4p. Okay? So I know 4p then is 7/3. So now I know in this spot, I'm going to have 1 over, whoops, I meant to say 7/3, sorry. I'm going to have 1 over 7/3 in this spot. So 1 over 4p is 1 over 7/3. This is a really tough problem with the fraction. But just think about that. What's 1 divided by 7/3? 1 divided by 7/3. Lizzie?
3 over 7?
Yeah, 3 over 7. So in this 1 over 4p spot, I'm going to have to put 3 over 7. And since my vertex is just 0, 0, it's just going to be y squared. That's a really tough one just because it's that fraction. Let me go through it again just real quick. P was 7/12. I wanted to find 4p so that I could figure out what would go down here. Unfortunately, 4p was a fraction, so I had to do 1 divided by that fraction. So then I said 1 divided by 7/3 would be 3/7. Okay? So in this case, 7 is not really 4p. Okay? All right. We're going to do one more of this word problem. The cross-section of a parabolic sound reflector at the Olympics has a diameter of 12 inches and is 25 inches deep. Write an equation that represents the cross-section of the reflector with its vertex at 0, 0 and its focus to the left of the vertex. All right, so let's try to understand what's going on here. So we have a vertex at 0, 0. Here's our vertex. What else do we know? The diameter is 20 and it's 25 inches deep. So if I come in like this, draw this parabola here, I know that this depth is 25, and I know that this diameter is 20. So what they're really telling me is this point and this point. Anybody know what those points would be? It has a diameter of 20, and this is 25 deep. What's it going to be, Charlie?
25, 10, 25, 10.
Mm-hmm. All right. And I know the vertex is at 0, 0. So we have to decide if we can find that p-value. Sometimes we can't. They didn't tell us anything about the focus or anything about the directrix. I can't find out that p-value. But I do know this much. I know that it's going to have to be, what, x getting squared or y getting squared? Y is going to have to get squared, so it's going to have to be x equals something y squared. Do I have to worry about a shift left and right? No, that's good news. I can't find out what P is, so I'm just going to have to call it A. Since I can't find out what P is, I got to go back to my old method. Yeah.
Wouldn't one of the points be negative 25, 10?
They would both be negative 25, 10. Thank you. One's positive 10, one's negative 10. All right, so now we're going to have to find out A, our old way, instead of our 1 over 4P way. You've got to be able to adapt. So I can choose either one of these points. I'm going to use this point. So X is going to be negative 25. Y is 10. So 10 squared is 100. And so A is going to be negative 25 over 100. So then that means that it's going to be X equals negative 1/4 y squared. Let's say that I'm taking a test and I'm going to get 10 bonus points if this is right. I would want to check this. Watch how I check it. I'm going to multiply both sides by negative 4 because I'm going to put this into the calculator. If I'm going to put this into the calculator, it's going to end up being negative 4x equals y squared. What do I have to do if I take the square root of something? Put what in front of it? So I would have this as my functions to put in. Watch what I'm going to do here to check this. So I'm going to have the square root of negative 4x, and I'm going to have negative the square root of negative 4x. Okay, so I'm checking this. I want to make sure it goes through these points. I really don't care what it looks like even. So I'm going to go to my table setup. I want to see this at negative 25. And I'll even make it go by 25s. Because I want to check these points. At negative 25, I'm supposed to have 10, and I'm also supposed to have negative 10. You see that? And 0, 0. So I can check it and make sure it's right. If I want to change my window to be able to see it, my x's are going to need to go from like negative 30 to maybe 10. I just want to see this whole thing. My y's, I'm going to have to go from like negative 15 to 15. Let's see if it looks the same. Yep. All right. Isn't that neat? We can check it all. All right. Any questions? Okay. So just a couple of additions to this with that